Okay, so now we want to look at the problem of the center of mass here. Okay, center of mass. And we started with our little seesaw picture where we had these guys being some distance. I'll call these x, and the things on the seesaw having some mass. So maybe we'll have something like this. Three masses on here. And what we said is that this thing is going to balance when the product of this distance and mass on this side is equal to the stuff on the other side, on the right side. In other words, that x1 times m1 equals x2 times m2 plus x3 times m3. And further, if we didn't know where the balance point was, what we could do to find it is we could say that this left endpoint over here is 0, and we could set up these distances from 0 accordingly and solve. So what we'll do is we will actually take all of those masses and add them together and divide them by the total mass, and that will be our first balance point. So for example, let's say that we've got some bar here, and we put one mass that is 6, and that's a distance of 3, and we have another mass that's like 8, and that's at a distance of 10. So what we're saying is that this should balance at 3 times 6 plus 8 times 10 divided by 6 plus 8, which would be 18 and 80, that's 98 over 14. And so I just have to figure out what that is. And I think that I can do that quick here. 98 divided by 14. And, oh, 7. Well, that makes sense. So, so then that tells us that we would be over here at 7, which seems to make sense, right? Like we'd be closer to the 10 than we would the 3, or the bigger mass than the smaller mass, right? We would have to creep over towards that guy. All right. So then the next thing is, what about in 2 dimensions? Well, what we do is we just have, let's say that we have a bunch of points out here. These all have x coordinates, and they all have y coordinates. So what we're going to do is we're actually just going to look kind of like from each axis at this thing as a balance. And so if I'm looking at the x-axis, the thing that's going to turn it around are going to be these distances. It's moving it around based on like the distance off of the x-axis here. So now I'm actually going to be interested in these y distances. So the propensity to turn it around x is actually determined by the sum of those y's times the mass over the total mass. And similarly, now if I look at the y-axis, I'll do the same thing. I'll say, okay, like what's going to turn it around this? And it's all of these x values. So the moment about y is the sum of these x sub i's times their mass over the total mass. And this is what we'll use to draw our mobile. So let's see how that might work if I take a 20-pound block. What I can do is I can start to separate that guy, and maybe I take and say, okay, here's 10, and here's 10. So these would be equal distances. Maybe I'll say this is 2 and 2. And then what I can do is I can take this 10 and maybe I'll split him. So instead I'll have a 10 over here. Over here I'm going to take and I'm going to split that and I'm going to rotate it down. And I'll say that this guy will be, actually now I'll get fancy. I'll say this guy is going to have 2 and this dude down here will have 8. And this is still 10. But I've got to figure out what that distance is, right? And we can then just treat this as like a little balance. And then subsequently, maybe instead of this 8, I have this piece down here. And now I've got this guy with this. And so maybe I take that 8 and I split him into a couple of pieces here. Now if these are both 4 and 4, this would be balanced in the middle. But again, what you want to do is you want to try and kind of divide them up to be different things. I don't think that you want everything to be exactly the same. You want a little bit of motion and different weights hanging, different size things hanging different places, and just continuing. And then you have what you have is something like that picture that we were just looking at. You have all your weights hanging. They'll be interconnected somehow. I don't know. And you just have to look again at the X and the Y, and you'll find your center of mass.